Okay, so in this lesson, we're going to investigate series and different tests of convergence of these series. So in this lesson, we're going to explore different tests that would help us, in fact, determine if a given series is convergent or divergent. Now, first, let me just start by recalling the difference between a sequence and a series, and in addition to the difference between the limit of the sequence and the limit of the series. So over here, if I start with a sequence defined by un, so the general term of the sequence is in fact here un. A sequence would in fact consist of the terms of the sequence listed. And over here you can see the terms of the sequence being listed from n equals to 1 all the way to infinity. Now, of course, sequences and series could be finite. They could stop at a certain rank. However, if sequences and series are finite, it's useless to speak of limits of sequences and limits of series. So it's infinite sequences and series that would in fact have limits. Okay, now, if we were to find the series corresponding to the sequence I just listed above, the series would in fact be the sum of the terms of that sequence. So over here, the sequence would consist of adding these infinite number of terms. And if I were to define as L the limit when n is approaching positive infinity of un. Now, so this is the limit of the sequence, because it's the limit of the general term of the sequence as n is approaching positive infinity. Well, let's just call S the limit of the series. So in fact here, where example I goes from 1 to n of ui. So this is in fact the sum of the series. So where do I in fact find each? For example, I just called L the limit of the sequence. So where do I find that limit in the sequence? In fact, the limit of the sequence is the limit at which the terms of the sequence start converging starting from a certain rank, which means that starting from a certain rank, all the terms of the sequence would in fact be approximately equals to L. Of course, this is a limit, so the terms would in fact be approximately equals to that limit. However, a series, the limit of the series would in fact be the value of the sum of the infinite number of terms in the series. So in fact, the limit of the sequence would in fact be the value over which or at which the terms of the sequence converge to, while the sum of the terms of the sequence would in fact be the limit of the series. Okay, so over here, if L is finite, in that case we say that the sequence is convergent. However, if the sum is infinite, if the limit of the sequence is infinite or not existing, in that case the sequence is said to be divergent. Okay? Similarly for S, which is the sum or the limit of the series, if it's finite, in that case the series is convergent, while if it's infinite or not existing, in that case the series is divergent. Okay? Now, how do in fact the limits of the sequence and series affect one another? So, first of all, if the sequence is divergent, which, for example, let me just give you a simple example. If the series is divergent, for example, if the sequence has an infinite limit, even though divergent sequence could mean that the limit does not exist. But, however, let's just visualize it this way. Suppose that the limit of the sequence is infinite. Okay, which means that starting from a certain rank, the terms of the sequence are infinitely big. So if these are infinite, when you come to add them here, then of course in that case, the limit of the series is infinite. So a sequence divergent leads to the series being divergent. Okay, however, if the sequence is convergent, does that mean that the series is convergent? Let's just take an example here. Suppose that the limit of the sequence is 2. Suppose that the limit of the sequence is 2, which means that starting from a certain rank, all the terms of the sequence are approximately equals to 2. When you come here and start adding that 2 to itself infinitely, that would still lead you to an infinite sum. However, if the terms of the sequence are in fact equals to 0, have a limit equals to 0. So if starting from a certain rank, all the terms of the sequence are zeros, then in that case, starting from a certain rank, you'll just start adding to the previous terms zeros. So which means that these numbers would no longer affect the sum. So does that mean that in this case, if the limit of the sequence is 0, does that mean that the series is definitely convergent? Well, in fact, no. It could be convergent, while it could also be divergent, because in some cases, which we will see about it later on, that in some cases, the series could have diverged before the sequence have reached its 0 limit. So you know that I've been mentioning from the beginning that starting from a certain rank, the terms of the sequence will converge to its limit. So starting from a certain rank, all the terms of the sequence are approximately equals to 0 if the limit of the sequence is 0. So in fact, when you add the terms before that rank, these could have an infinite sum, and in that case, the series could be divergent. So when a sequence is convergent, it would in fact imply that the series is divergent or convergent. However, if the sequence is divergent or have a limit that is different than 0, then we can definitely say that the series is divergent. But if the limit of the sequence is 0, in that case, the series could be divergent or convergent. So in that case, we'd need to use other tests of convergence. So over here, if we move to the next slide, which in fact includes the nth test for divergence, which is what we were just discussing right now. Okay, so the nth test of divergence, the nth term test is in fact used to determine if a series is divergent. It cannot really tell us if a series is convergent. So based on the investigation we just did, if a sequence is divergent, then the series is divergent. If a sequence is convergent, then the series would diverge if the sequence has a limit different than 0. Well, if the limit is equals to 0, then the test is inconclusive. The test being inconclusive, it means that it does not really tell us anything about the convergence of the series. We'd really have to use another test. Okay, so for the Unstirred test for divergence, all you have to do is just study the limits of the sequence in order to determine if a series is divergent. For example here, if we just look at these three series in part A, you'd notice that in part A, this is a geometric series. Well, you'd in fact here be multiplying by 3/4 every single time. So here, if I call this S, S would be the sum where n goes from 1 to infinity of the first term times the common ratio to the power of n minus 1. So this is the general term of the sequence. However, geometric series are a very particular case because we already know that if the absolute value of r is smaller than 1, then the series is convergent. Okay, and over here we have r to be equals to 3/4, which is smaller than 1, then this geometric series is convergent. Now this is a geometric series. However, if we look at part B, the sum S consists of the sum when n goes from 1 to infinity of n over n plus 1. So if I just call the corresponding sequence un, where the general term of un is n over n plus 1. So over here, I could start by studying the limit of un as n goes to positive infinity. Now over here, the limit when n goes to positive infinity of n over n plus 1 is infinity over infinity, which is indeterminate. You could cancel that indetermination by taking the terms of the highest degree, since it consists of polynomials at infinity, or you could just apply L'Hopital's rule. So both cases, that would lead to a limit equals to 1. So you'd notice, even though the sequence is convergent, but it converges to a limit that is different than 0. Okay, so in that case, we deduce that S is divergent. However, in part C, we're looking at S, which is the sum when n goes from 1 to infinity of 1 over n. So let's just call the corresponding sequence un. So the limit when n is approaching positive infinity of un is in fact the limit when n is approaching positive infinity of 1 over n, which is 0. So the sequence here is convergent, and it converges to a limit equals to 0. However, this does not tell me anything about the convergence of the series. So over here, I can just say that the test is inconclusive. Inconclusive, which would actually mean that S could be convergent or divergent. This test does not really help us determine. Okay, so next we're going to start by exploring different tests of convergence of series. Now, in this video, we have explored quickly the difference between a sequence and a series, and the difference between the limit of the sequence and the limit of a series. And we've also discussed the nth term test for divergence, which is a test that could also tell you if a series is divergent. If a series is divergent, it does not really tell you if a series is convergent. So following this video, you will in fact be introduced to tests of convergence of series.